In this video, we are going to talk about circular motion. So circular motion, in some books, they are going to say it is rotational motion. So when you hear circular motion and rotational motion, we are talking about the same thing. Okay. So what is circular motion? So when an object rotates, that's circular motion. So when an object is moving around the circle, we can call that as a circular motion. So what are some of examples of circular motion? We can see that when a car is moving around the circle, that is circular motion, which is happening there. The sun around the orbit, that is circular motion. Okay. The clock ticking, that is circular motion. Helicopter rotor blades, that is also circular motion. We can also talk about the fan blades. That is also an example of circular motion. Okay. Now let's talk more about this circular motion. Now we have talked about linear motion. So I want us just to see the relationship which is going to be there between the linear motion and the circular motion. Okay. Now linear motion is a motion when an object is moving in the x direction or in the y direction. Okay, where we are talking about it, when an object is moving in x or even in y direction, we can call that one as a linear motion. Okay, so an object moving in x direction, we talked about this. An object moving in y direction, we talked about this, which was free fall motion. Okay, now the linear motion, when an object is moving along the straight path, it can either be in x or y direction. That is what we call linear motion. Now linear motion is what we call translational motion. Okay, an object moving in a straight path, we call it translational motion or linear motion. Okay, then when an object is moving around the circle, that is what we call rotational motion. Okay, or circular motion. Now we are saying that circular motion is when an object moving around the circle. Now let's come up with a circle. So here is my circle. Let's say this object is moving from uh, this point here all the way to this point. Okay, so meaning that this is the center of the circle. This object is moving from this point, okay, all the way to that point. Now there is an angle which is going to be formed, and that angle we are going to call it theta. The distance this object is going to cover from this point all the way to this point is what we call the arc length. Okay, so there is my arc length. Okay, now the distance from the center of the circle all the way to where uh, the circle is, that is what we call the radius. So here is my radius. Now there we go. Theta is given by the arc length divided by the radius. In short, you can see the opposite here, then here is more like the hypotenuse. Meaning that if I want to find the arc length, I can say that the arc length is going to be, if I cross multiply, is going to be the theta times the radius. Okay, so we have to know this formula. We also need to know this formula. Now let's talk more about the theta. This theta is what we call the angular displacement, and the SI units for this, you can either say it's in degrees or it's in radian per. It's just rad. Okay, so we are saying that this theta is what we call, it is the angular displacement. This is also very, very important for us to know. Then we are saying that S is just basically the arc length. Okay, R is the radius. That is also very, very important. We have to know this. Okay, now let's talk more about this theta. Okay, let's talk more about the angular displacement. So I'll get rid of this. Let's talk more about angular displacement. Now, if an object is moving from, it has moved from this point, let's say the first point is here, we are going to call this one as the theta initial. Then the second point is there, we are going to call that other one as the theta final. Meaning that we're going to have the change in theta to be equal to the theta in final minus the theta initial. Okay? Now, we also know that when this object moves from this point all the way until back to its original point, that is the circumference of the circle. So what is the circumference of the circle? The circumference of the circle is just basically 2 pi r. So we are going to use this. This is very, very, very important. We have to know this. Okay? Now, we are saying that this theta, which we call the angular displacement, we are saying that it is in rad. Okay? So now, what if you move the whole circle? We know that it's going to be 360 degrees. This 360 degrees is the same as one revolution. So when you come from this point, you cover the full circle, that is one revolution. You go another one, the second revolution. You go another one, the third revolution. So in one revolution, there is 360. At the same time, there is 2 pi rad. Okay? So this conversion, we have to know it. It is also very, very important because we're going to be using this to convert our theta, our angular displacement or our angular velocity to be rad per second, or just to be rad from maybe revolution or maybe from degrees. Okay, now that we have talked about the angular displacement, let's talk about the velocity. Now we do know that when an object is moving, we're going to have the velocity. Now when we're talking about the translational motion, which is the linear motion, we're calling it to say that is the linear velocity. Now, when an object is moving around the circle, we have got what we call the angular velocity. Angular velocity it is represented by the symbol omega. So angular velocity, we know that the velocity, the linear velocity, it is the distance divided by time. Now, in this case, this is the linear displacement. Now, when we go to circular motion, this linear displacement is going to be the angular displacement, which is going to be the theta divided by the time. Now, this we can call it the average angular velocity. So the average angular velocity is given by the angular displacement divided by the time. Okay? At the same time, what we have to remember is that this theta, if it is 360 degrees, then it's going to be 2 pi. But we're going to talk about this more later. Now let's talk about the angular acceleration. If we have velocity, we expect to have the angular acceleration. Angular acceleration is represented by the symbol alpha. Okay, so this is going to be the average angular velocity divided by what? Divided by the time. Okay, so if you want, you can say the change in angular velocity time, the change in time, where you are going to have the angular final minus initial divided by the time. This is also very, very important. Now, when we're talking about linear motion, the angular acceleration is what we call the linear acceleration, which is represented by a. Okay, so now we're going to talk about these guys when we start talking about the relationship between the circular motion and the linear motion. Okay, so for this part, let's now see how we can solve some questions from what we have done so far. So I have the first question here, which is saying a compact disc has a diameter of 12 centimeters. A point on the limb move through a single an angle of 150 degrees. How far does this point move in centimeters? So we can see that we have the disc. It moves, this is the center of the circle, so it moves from this point all the way to there, and the angle here is 150 degrees. Okay, so it has moved from this point all the way to that point. So the radius is, this is the diameter, meaning the radius is 6 centimeters, because the diameter is from this point all the way to that point. So on the middle here, meaning it's going to be divided by 2, which is going to be 6. Okay, so it's 6 meters. Our goal is to find the arc length. That's why the question is saying how far does this point move in centimeters. So we want to find the arc length. Remember, the angular displacement is given by the arc length divided by the radius. Our goal is to find the arc length. We can see that the arc length is going to be the theta divided times the radius. Now we have the theta in degrees. Remember to convert this always into rad. So we said 360 degrees is equal to 1 revolution. At the same time, it is equal to 2 pi rad. So now if we've been given degrees, we can see that that degree, if we want to convert it to rad, we are going to use this to say 360 degrees is equal to 2 pi rad. Okay, at the same time, if we have been given in revolution, we're going to say 1 revolution is equal to 2 pi rad. So now in this case, I've been given in degrees, so I'm going to say 150 degrees, okay, times, my goal is to cancel the degrees. So I'm going to say in 360 degrees, how many rad do we have? We have 2 pi rad. So at this point, we can see that the degree and degree will cancel. Okay, this and this will cancel. We're going to have 150 times 2 pi, then we divide it by 360. Okay, so if I put my calculator, this is going to give me 2.6 2.61 or 2.617, which is just the same as 2.67, meaning this is my what? This is my arc length, which is going to be in meters. Okay, now this this is the theta, the angular displacement, which we have just converted here. Now we have to plug in this formula to find the answer. So this is the rad, it's supposed to be in rad. Okay, so this is going to be in rad. That is my angular displacement. Now that we have found our angular displacement, let's see what our arc length is going to be. So our theta, we are saying that our theta is 2.62 rad. Now our goal is to find the arc length. So our arc length is going to be, the theta is 2.62 times the radius. Now the question is asking us to find the answer in centimeters. If I want, I will just plug in direct 6 centimeters because I want my answer to be in centimeters. Or if you want, you can convert and then you're going to convert the answer again. So if I want to use direct, I'm going to find that my arc length is going to be 2.62 times 6, which is 15.72 centimeters. I've done it direct because the question is asking me to find the answer in centimeters, and I also know that the arc length is in centimeters. Okay, but if I want, I can convert, but I'm going to find the same answer. Okay, let's see if we're going to find the same answer. So if I'm to convert this radius, it's going to be 6 divided by 100, which is going to be 0.06. So I'm going to have my 0.06 here. So my arc length is going to be 0.06 times 2.62, which is going to be 0.1572 meters. Now the question is, we leave it in centimeters, so it's going to be times 100. So if I do times 100, my arc length, I'm going to get 15.72 centimeters. So that is it for this question. So let's go to the next question, which is saying the rotor on a helicopter. Remember, we said when the rotor is spinning, that is an example of circular motion. So here the question is saying the rotor on a helicopter turns at an angular speed of 3.2 times 10 to the power 2 revolution per minute. Express this angular speed in radian per second. But B, if the rotor has a radius of 2 meters, what arc length does the tip of the blades trace out in 3.00 times 10 to the power 2 seconds? By the way, we have talked about the angular velocity, where we said the average angular velocity is the change in theta divided by the change in time. Then we say the angular acceleration, or the average angular acceleration, is the average angular velocity divided by the time. Okay. Then we also said we have what we call the linear displacement, which is the theta. Now we have said that the SI unit for linear displacement, it is in rad. What of the angular velocity? So the angular velocity, instead of saying it is meters per second it is for linear velocity. But the angular velocity, since we are talking about the rad for the angular displacement, is going to be in rad per second. Sometimes in some books you're going to see they're going to say it's revolution per minute. But in most cases we're going to be using rad per seconds. Okay, so if you have seen revolution per minute, you have to convert it into what? Rad per seconds. What of the angular acceleration? The angular acceleration, it can be in rad per second squared or revolution per minute squared. But in most cases the SI unit has to be these two. So if you see them in these, you have to convert it into rad per second. Okay, now we can solve this question. So our question is saying we have to convert that angular speed which we have to revolution per what, to rad per second. So we have 3.20 times 10 raised to the power 2, that is revolution per minute. So what we have to do here is this is the same as we have 3.20 times 10 raised to the power 2 revolution divided by in 1 minute. So I'll say times. So I'll say in one revolution, how many rads do we have? We have got 2 pi rad, because we're trying to put our answer in radian per what? Per second. Okay. Then next I'm going to say in 1 minute, how many seconds do we have? We've got 60 seconds. So as we can see, the revolution and revolution will cancel. The minute and minute will cancel. On top, I'll remain with rad, which I want. Down here, I'll remain with seconds. Okay, so I'm going to have 3.20 times 10 to the power 2, then times 2 pi. So I'll divide this with what? A 60. Okay, so I'm getting my speed in rad per second to be 33.51 rad per second. Okay, so that is my angular velocity. Remember, angular velocity is represented by the symbol omega. Then the angular acceleration is represented by the symbol alpha. So now the second question is saying, if the rotor has a radius of 2 meters, what arc length does the tip of the blade trace out in 3 times 10 to the power 2 seconds? Okay, so we are trying to find the arc length. Remember, the theta, the angular displacement, is equal to the arc length divided by this. Our goal is to find the arc length, which is going to be, the arc length is going to be the angular displacement times the radius. We have the radius, we don't have the angular speed, or we don't have the angular displacement, sorry. Now, to find the angular displacement, we are going to use the formula for angular speed. Angular speed is given by the angular displacement divided by the time. We have the time. My goal is to find I have the angular speed already. So I'm going to say the angular displacement is going to be, the angular speed is 33.51 times the time is 3.0 times 10 to the power 2. So my angular displacement is going to be 33.51 times 3.00 times 10 to the power 2, which is giving me 10,053, that is in lad. So angular displacement is supposed to be lad. Now that we have our angular displacement, let's plug in the values. We find the arc length. So we have 10,053 times the radius is 2. So we expect our to be 20,106. That is going to be now in meters. Okay, that is our arc length. If you want, you can put it in scientific notation, where you are going to say this is the same as 2.01 times 10 to the power 4 meters. It's also the same. So that is it for the introduction of circular motion. Let's talk about the relationship between the rotational motion and translational motion. So rotational motion is the circular motion. When we talk of translational motion, we're talking about linear motion. Okay, when an object is moving in a straight path. Okay, now when we're talking about translational motion, which is linear motion, we know that we're talking about the distance, the velocity, and the acceleration. Okay, now there's a relationship which we have to come up with here, the relationship which is going to be there between the linear motion and the circular motion. So in this case, I've said the relationship between the rotational motion and the translational motion. Now, when we talk about this, is what we call the linear displacement. Okay, this is the linear displacement. This is what we call the linear velocity. This is what we call the linear acceleration. Why are we saying this is a linear acceleration? Because it is in reference to what? The translational motion, which is the linear motion. That's the reason why we're saying it is linear displacement. Now, when we come to circular motion, this D is represented by the theta. So this is what we call the angular displacement. The velocity is represented by the symbol omega in circular motion, which we call the angular velocity. Then the acceleration is represented by a symbol alpha, which we call the angular acceleration. Now this is what we call the rotational motion. Rotational motion, which is circular motion. This is what we call translational motion, which is linear motion. Translational motion. Now, what we have to understand is that when you are talking about linear motion, this linear displacement, the SI unit is in meters. Okay, that is also very, very important. We have to know the velocity, the linear velocity, the SI unit is meter per second. The angular acceleration, the SI unit is meter per second squared. Now let's go to rotational motion. When we're talking about the angular displacement, the SI unit is lad. The angular velocity, the SI unit is lad per second. The angular acceleration, it is lad per second squared. Now, we have to build up something here. Okay? We have to build up something here. Now, we are saying that we have the linear and the angular. Okay? Now, we are saying that the angular velocity, these are the formulas which you have to know, the relationship which is there. The angular displacement is given by the the linear displacement is given by the angular displacement times the radius. The linear velocity is given by the angular velocity times the radius. The linear acceleration is given by the angular acceleration times the radius. These are the most important relationship which you have to know for now. This is very, very important. Okay? Now, let's talk more about the relationship now. So I'm going to put this just here. I'll say I have okay, let me just get rid of them. So let's now talk about the translational and the angular. Okay, which is so I'll do this. Then I'll put here, I'll put this. I'll start with the translation. Translational motion, which is linear motion. Here I'll put rotational motion. Okay, now the first formula on a translational motion or linear motion, which we know already, is the first equation of the motion, which is the v final is equal to the v initial plus this. The second formula which we know is the change in displacement is equal to the v initial times time plus half acceleration times t squared. Now, another one which we know is the v final. Okay, another one which we know is the v final squared is equal to the v initial squared plus 2a times change in displacement. Now, what we have to understand is that when we are talking about these three formulas, they are the ones which we use in linear motion or translational motion. Now, when we're talking about rotational motion or circular motion, when we talk about the velocity, this is linear velocity, meaning there we are going to be talking about the angular velocity. Angular velocity is represented by the symbol of omega. So it's going to be omega final is going to be equal to the omega initial plus the acceleration is the angular acceleration times t. T doesn't change. The next one is going to be the theta is the equivalent of what? The linear displacement. Okay, so this is going to be equal to the omega initial times time plus half angular acceleration times t squared. Next we have the omega final squared is equal to the omega initial squared plus 2 angular acceleration times change in the theta. So this is the relationship which is there, which we have to know. This is very, very important. So these are the formulas which you have to be familiar with, the three ones. But we also need to know this. Now this is under linear motion. But we have also come up with three formulas which you have to know. Those three formulas, they are very, very, very much important. Okay, we have said that the linear displacement is equal to the theta times r. The linear velocity is equal to the angular velocity times the radius. The linear acceleration is equal to the angular acceleration times the radius. We have also to know this. So these are the only formulas which we have to be familiar with. Okay, so we have 1, 2, 3, and we also have 3 there, which there are 6. Now that we have come up with the relationship between the translational motion and the rotational motion, let's see how we can solve the questions. So the first question is a wheel rotates with a constant angular acceleration of 3.50 rad per second squared. If the angular speed of the wheel is 2.00 rad per second at t is equal to 0. But through what angle does a wheel rotate between t is equal to 0 and t is equal to 2 seconds? Give your answer in radians and revolution Part B, what is the angular speed of the wheel at t is equal to 2? Part C, what angular displacement in revolution result while the angular speed found in part A in part B doubles? Okay, so now it is very important if we can first come up with the data. So once we come up with the data is going to help us to know which formula we're going to use. Okay, so let's come up with our data here. Now we can see that we have our initial velocity here. This is when t was equal to 0, meaning that was the initial velocity. The velocity was 2.00 rad per second. The final angular velocity we don't know. Okay, what else do we know? We also know the angular acceleration to be 3.50 rad per second squared. What else do we know? So these are the only things which we know for now. Now, the question is, we also know the time. This is when the t was equal to 0. Okay? But we also have the time when it was 2 seconds. Now, the first question is we need to find the angle, which is the theta. Using the relationship which we have just talked about, we can see that this formula can work. Because I have everything here. So the time in between 0 to 2 is going to be just 2, because it's 2 minus 0 is going to be 2. Okay? So I'm going to have the theta to be equal to, okay? So I'm going to have the angular speed is 2 times the time, which is 2. Okay? Or the angular speed is 2, yes, the time is also 2, then plus half the angular acceleration is 3.5 times the time is 2. Now we have to square it. The theta which we're going to find here is going to be in rad per in radian. So we're going to have, this is going to give us a 4 plus we're going to have 0.5, because 1 over 2 is 0.5 times 3.5 times 2 squared is 4. So I'm going to have 7. So I expect my theta to be 11 rad. So the first part we will find that the theta is 11 rad. Now they are saying that we need to find this also in revolution. The angle has to be in revolution as well. Remember, in one revolution, we have got 360 degrees. At the same time, we've got 2 pi rad. Now, I want to convert 11 rad to revolution. I'm going to say times. I'm going to set the units in such a way that they should cancel each other. Okay? So, in one revolution, how many rad do we have? We have 2 pi rad. So, I'm going to say 11 times I'm going to set the units in such a way that they should cancel each other, meaning that this has to be on top, because I want to find so in one revolution there is 2 pi rad and not the opposite. So it's going to be 11 divided by what? So I can see that I can cancel the rad here. So cancel the rad and rad will cancel. I'm going to have 11 divided by 2 pi, which is going to be 1.75 revolution. So we have find the theta to be 1.75 revolution, and in rad is 11. So that is it for question A. Now let's go to question 2, which is B. Question B is saying, what is the angular speed of the wheel at t is equal to 2? So when t was equal to 2, what is the angular speed? That is the question. Okay? So in this case, I can use the first equation where I can say the angular final is equal to the angular initial plus alpha times t. So I'm trying to find the initial I have. I'm trying to find this other one. So I'm going to have the angular final. This one is 2 plus 3.5 times 2. So the angular final is going to be 2 plus this time this is 7. So I'm going to have my angular velocity in this case to be 9 rad per second. Okay, now part C is saying, let's put it here. Part C is saying we have to find what angular displacement in revolution result while the angular speed found in part B doubles. Okay, so we want to find the angular displacement now. If the speed has been doubled, meaning we have now two speeds, we have the initial and the final. So we can use this. So we shift this one to the other side. We are going to have, I'll divide both sides by 2 alpha, 2 alpha. So this has to be doubled. That's what they're saying. So I'm going to say the theta is going to be the I'll have this. Let's plug in the values. We see what we're going to have. So if I double the one I found here is going to be 2 times 9. Then I have to square it. Minus 2 squared divided by 2 times the angular acceleration is 3.5. So let's see what we're going to have. So I'm going to have theta to be, this is going to be 18. So what is 18 squared? 18 squared minus 2 squared. So I'm getting 320. I divide it with 2 times 3.5 is 7. So I'll get 45. 45.71 lad. They want the answer to be in revolution. I'll convert this into what? Revolution. So I know that 45.71 lad times in 1 revolution there is 2 pi lad. I'll cancel these 2. So I'll have 45, I divide it with 2 pi. So I'll have 7.27, which is the same as 28 revolution. So that is it for this question. Now let's go to the next question. We have a compact disk rotate from rest up to an angular speed of 31.4 lad per second in a time of 0.892 seconds. What is the angular acceleration of the disk? Assuming the angular acceleration is uniform, through what angle does the disk turns while coming up to the speed? But see, if the radius of the disk is 4.45, find the tangential speed of the microbe riding on the limb of the disk when t is equal to, this is supposed to be t is equal to, when t is equal to 0.829, but d, what is the magnitude of the tangential acceleration of the microbes at a given time? Okay, so there we go. So let's come up with data. What do we know? A compact disk rotates from rest. The initial angular velocity is 0. The final is what we have been given, 31.4. What else do we know? We know the time, 0.892 seconds. This is lad per second. What else do we know? We also know the radius. So the radius of the disk, we have been told that it is we have been told that the radius is 4.45. So we have to convert that one into meters. So 4.45, I'll divide it with 100. I'll get 0.0445 meters. Okay, we are done with the data. The first question is saying, what is the angular acceleration of the disk? Assuming the angular acceleration is uniform. So how do we find the angular acceleration in this case? Okay, so I can use this formula. the final angular velocity is equal to the initial angular velocity plus angular acceleration times t. I shift this to the other one. I have this. I divide both sides by t, even here by t. Angular acceleration is going to be given by the final, not squared, but just the final minus the initial divided by the time. Let's plug in the values. The final is 31.4, okay, minus 0 divided by the time is 0.892. Let's see what we're going to have. So 31.4 divided by 0.892. So I'm getting 35. Okay, so I'll put it here. So the first answer is I'm finding my angular acceleration to be 35.2. 35.2 rad per second squared. So that is the answer for part M. Now this answer I can just put it here and I say is 35.2 rad per second squared. Let's go to part 2. Part B is saying through what angle does the disk turn while coming up to this speed. So they want to find the angular displacement. Now, given the information which you have here, how can we find the linear displacement? Okay, we can find the linear displacement using the third formula to say the angular squared minus, or has to be equal to the initial plus 2 alpha theta. Our goal is to find the theta. Okay, now we are going to shift this. This one is going to come here. We're going to say this is going to be 0, or let me just put the formula first. I'll shift that one. This has to be squared, has to be equal to 2 alpha theta. We divide both sides by 2 alpha. 2 alpha theta will be equal to divided by 2 alpha. Let's plug in the values. We see what we're going to have. So theta will be equal to the final velocity is 31.4. We square it minus 0 squared, everything divided by 2 times the angular acceleration is what we have found, 35.2. So let's see what we're going to have. Let's get rid of this. So alpha is going to be 31.4 squared minus 0 squared. I divide this by I'll put the brackets, or what we can do is I can just do direct 31.4 squared. Let me first find what is down there. 2 times 35.2, which is 70.4. So my theta is going to be, I'm going to say 31.4 squared divided by 70.4, which is giving me 14.0. Okay, so 14.0 rad, that is going to be my angle. Now in this case they're saying through what they have not specified to say we should put our answer in radian or revolution. So the answer is going to be in rad always if they have not specified. Okay, so that's the answer for part B. Part C is saying if the radius of the disk is 4.45, find the tangential speed of the microbe gliding on the limb of the disk. Now remember, the tangential speed is the same as the linear speed. Okay, same as tangential acceleration is the same as the linear acceleration. So If you can remember very well, we came up with this formula. Let me just put this theta here, 14.0 lad. Let's get rid of this to create space. Remember the relationship, the formulas which we just came up with. We said the linear displacement is given by theta times r. The velocity is angular times r. The acceleration is angular acceleration times r. The question here is, find the tangent if the radius of the disk is 4.45 centimeters. Find the tangential speed of the microbe riding on the limb of the disk when t is equal to 0.85. So when t was equal to 0.85, the speed is 31. Okay, so we want to find the tangential speed. There we go. We're going to say the tangential speed is the same as the linear speed. So linear speed is given by the angular speed times the radius. So when t was equal to 0.892, the speed was 31.4. Okay, so the linear speed is going to be, the speed is 31.4 times the radius, which is 0.0445. Let's see. So the linear speed is going to be 31.4 times 0.0445. So the linear speed is going to be 1.3973, which is just the same as 1.4 meters per second. So this is going to be my tangential speed. Okay, the next question is saying, what is the magnitude of the tangential acceleration of the microbe? So the tangential acceleration is the same as the linear acceleration. So linear acceleration, we can use this to find the linear acceleration. So we're going to say linear acceleration, the angular acceleration is 35.2 times the radius is 0.0445. So the linear acceleration is going to be 35.2 times 0.0445. So I'm getting 1.57. So this is meters per second squared. So it is also important for us to know the relationship which is there between the linear and the angular. Okay, so now we can see that we have found the what? Both party C and D using the relationship which we have just come up with there. Okay, so that is also very, very important. But at the same time, we know that acceleration, if you want to use another formula, for example, where there is tangential acceleration, you can do this. We know that acceleration is equal to the V final minus V initial divided by the time. The V initial is 0. Acceleration, the velocity at this point, we have found this. This is what we're talking about, which is 1.4. I divided with time, which is 0.892. So if you find this, you're going to find 1.569, which is the same as 7 meters per second squared. You're going to find the same answer. But the relationship which you have to know is the same one, to say the angular speed, the linear speed is equal to the angular speed times the radius, which is this one. Then the angular displacement is the linear displacement is the angular displacement times the radius. Okay. Now let's see how we can solve another question, which is question 3. An electric motor rotating a workshop grinding wheel at a rate of 100 revolutions per minute is switched off. Assume the wheel has a constant negative angular acceleration of magnitude 2 times 2 rad per second squared. But A, how long does it take for a grinding wheel to stop? But B, through how many radians has a wheel turned during the interval found in part A? So let's carve our data. Data is going to help us to know which formula we're going to use. Let's see. An electric motor is guiding rotating at this is switched off, meaning that this is the initial speed, which is 100 revolution per minute. So the final, since it came to stop, is 0. The angular speed, if it was decelerating, the angular speed is negative 2 rad per second. That's why they are saying with a constant negative angular acceleration of magnitude that. What else do we know? That is what we know only. We have to convert this to rad per second. So we are going to say 100 revolution in 1 minute times in 1 revolution. How many rad do we have? We have got 2 pi rad. In 1 minute, how many seconds do we have? We have got 60 seconds. So as you can see, these two they will cancel, these they also cancel. So I have rad on top, so I have 100 times 2 pi. I divide this with 60. So I'm going to get now my angular speed in rad to be 10.47 rad per second. So this is what I'm going to put here, because we have just converted this to 10.47 rad per second. Okay, now we can solve these questions. The first question is saying how long. They're asking about the time. Okay, we have the initial, the time, the angular velocity. I can use the first equation. We want to find the time, so I'm going to say I'll shift this to the other side. I'll have this. I'll divide both sides by the alpha, even here alpha. So time will be equal to the final minus the initial, everything divided by the alpha. Let's plug in the values. The final is 0. The initial is 10.47. The angular speed is negative 2. So what will be our time in this case? In this case, our time is going to be negative and negative will be cancelled. We're going to have 10.47 divided by 2, which is going to give me 5.235. So I'm going to have 5.235, which is the same as 24 seconds. That is going to be my time. Okay. Now, another question now here is part C. Part C is saying, through how many radian has the wheel turned during the interval found in part A? So now they are asking about the time which we have just found here. This is seconds, by the way. Let's not be confused. Not 5, it is seconds. So now we want to find the theta in short. We have the time, so we're going to use this. Okay. Initial times t plus half angular acceleration times t squared. Initial is 0. This is going to be cancelled. Theta will be equal to half alpha t squared. So theta will be half. What is the angular acceleration? So angular acceleration, we have been told that it is what? Negative 2. Okay, and we have said that the initial, we have the initial velocity. The final is the one which is 0. Okay, I was thinking maybe the initial velocity is 0, but no, the initial velocity we have, but we don't have the final velocity, which is 0. So using this formula, we can see that if we plug in the values, the initial velocity is 10.47 times the time 5.24. Okay, plus half the angular speed, the angular acceleration is negative 2. The time is 5.24 squared. So theta will be equal to, if I do 10.47 times 5.24, this is going to give me 54.55. Because of that negative which is there on 2, I'm going to say minus. So I'm going to have the time. I'll start with the time first. Okay, or I can start with there. 1 over 2 is 0.5 times 2 times, I'm going to have 1.24. Now I have to square that time. So I'm going to get 27 point, I'm going to get 27.46. Okay, my theta now is going to be 54.55 minus 27.46. This is going to give me a 27 as well. So I'm getting 27.09, which is the same as just 1 lad. Okay, so how many radian has the wheel turned? It has turned 27.1 lads. So that is it for this question. Let's see how we can solve another question. So question 4 is saying a car initially traveling at 29.0 meters per second undergoes a constant negative acceleration of 1.75 meters per second squared after it brakes, or after its brakes are applied. How many revolutions does each tire makes before the car comes to a stop? Assuming the car does not skid and the tire have a radius of 0.33 meters. But B, what is the angular speed of the wheel when the car has traveled half the total distance? Okay, so now let's come up with the data again. So we have our data. So they are saying that a car initially traveling, meaning we have the angular, we have the velocity, not the angular, but the linear velocity initial to be 29 meters per second. When it comes to stop, the final velocity is 0. We have been told that the acceleration is 1.75 meters per second squared. Okay, the question now is how many revolutions does each tire makes before the car comes to stop? Okay, we also have the radius to be 0.33 meters. So we have first to find the linear displacement. So the linear displacement is going to help us to find the what? The angular displacement. So I'm going to use this formula. The initial squared plus 2 acceleration times d. So my goal is to find the d. V final squared minus v initial squared is equal to 2a d. I'll divide both sides by 2a. Even here 2a. These two cancel. I'll have my d to be equal to v final squared minus v initial squared divided by 2a. Let's plug in the values. So my d is going to be equal to, the final is 0. So the initial is 29. Now I have to square it. Okay, I have to square it. What else do we have? We can also see that we have the 2 here times the acceleration. They are saying that it has a negative, so it's going to be negative 1.75. Okay, so we expect negative and negative to cancel. So I'll get rid of this, what is on top there. So I'll say my d is going to be 29 squared is negative 841 divided by what is negative 1.75 times 2. I'm going to get negative what? 3.5. Let's divide. Negative and negative will cancel. I'll have 841 divided by 3.5. So I'm going to have 240.3 lad. Sorry, this is going to be in meters because we're finding the distance now. Now, after finding this, we have to use that relationship for us to find the revolution now. But first, we're going to find in LAD. So we're going to say the angular displacement is equal to the theta times r. Our goal is to find the theta. We'll divide both sides by r. So theta will be equal to, we're going to have the d divided by the r. So let's see, the d is 240.3 divided by the radius, which is 0.330. So our theta in LAD is going to be 240.3 divided by 0.330. So this is giving me a 728.2 LAD. Now the question is, we have to put the answer in revolution. Okay, so to convert this, we are going to say that is the distance now in LAD. So let's see what we're going to have. The distance, we have found that in meters it is 240.3 meters. Now I can get rid of this. The question is, we need to put our answer in revolution. So in revolution, we are going to say 728.2 LAD. How many revolution? I'm going to say in one revolution, how many LAD we have? We have got 2 pi LAD. So these two will cancel. This answer divided by 2 pi. So I'm getting 115.9 revolution. So my distance in revolution is 115.9 revs. As simple as that. Now, part B is saying, what is the angular speed of the wheel when the car has traveled half the total distance? So the distance has to be half. So what is the angular speed of the car? Okay, that is the question. Now, to find the angular speed, if we want first, we can find from what we have here, from the answers which we have just come up with here, we can find the speed when the distance is half. Then after that, we have to find, we change now that one to, what I mean is I can say the final velocity is squared, is, because we don't have time, is equal to the initial speed plus 2ad. Now the distance, this is the distance which we're talking about. If this distance is half of this distance, then if I find the velocity, that is going to be now the final velocity. That velocity, I'm going to use the relationship to find the angular velocity because I have the radius. So what is the final velocity? The initial, we have been told, is what? Is 29 squared plus 2. The acceleration is negative. Is going to be what? It's negative because it is decelerating now. Okay, so I'm going to say negative 1.75. Now half of the distance is going to be 1 over 2d. Okay, so the final speed is going to be 29 squared is the same as I have minus, it's going to be 2 times 1.75 times half the distance, meaning I have 0.5 times 240.3, which is going to give me 120.15. Okay, so now v final squared is going to be now equal to, what is 29 squared? Is 841. So this is going to be minus, I have 2 times 1.75 times 120 times 120.18. Okay, that is 15, not 18. So I'm going to get 400 420.53. Now this is what I'm going to do. I'll get rid of this, then I'll say I'll do v final is going to be equal to 841 minus 420.53. This is going to give me 700 and it can't be 700 because it's 841, okay, minus 420.53 is giving me 420. Okay, it's giving me 420, so I'll put it here, 420.47. now I get the square root of both sides. My v final, when the distance was half, is going to be, what is the square root of 420.47? So my velocity is going to be 20.5 meters per second. So that is it for this question.
Are you enjoying this video lesson? So you can actually access the entire topic you are watching, or the entire practice questions of a video that you may be watching right now. So if you go to our website is transcendedinstitute.net. Okay, so there are three ways that you can access our videos. So you can use Patreon, you can use channel memberships. If you're in a country where it's allowed, you'll be able to access our full topic videos and full practice questions. So alternatively, you can access the videos using our learning portal. The link is learn.transcendedinstitute.net. So I'll show you a few videos that you can have access to after registering. So for example, if you had to open mathematics as at now, these topics are the ones that are available, which you can learn from scratch. I can just give you an idea of, so you like learn everything from scratch, meaning that even if you're learning something for the first time, these videos are there to help you with concepts as well as practice questions. So for example, these are tutorial sheet solutions from different tutorial sheets, which can help you as well get to learn faster and remember. So binomial as well, there it is. And of course, this applies to all these other topics that are available. Trigonometry as well, calculus, depending on the topic that you're interested in mathematics. So you can just head over to the site at now to check what is currently available. Even without registering, you should be able to see the content in each topic. So let's assume you're interested in physics. These are the topics available as at now. So if you open chemistry, these are the topics available as at now: electrochemistry, stoichiometry, thermochemistry, kinetics, equilibrium, solubility, equilibrium, atomic structure. So trust me, if you open these videos, you might have learned the topic in full. Let me show you stoichiometry. So stoichiometry, we have all the way up to 21 videos, including the tutorial sheet solutions, which will help you to practice both the concepts and also prepare for questions. Okay, so feel free to head over to the site and check out these videos on your own. So equally biology videos are also available, which you can also basically get to access. So these are the topics available so far. Yeah, so pretty much these are the ways you can easily access our full membership videos that you don't have access to on the channel.
Now let's talk about centripetal acceleration. So what is centripetal acceleration? Remember we said when an object is moving around the circle, that is circular motion. Okay, now let's have a circle. Okay, so here is my circle. When an object is moving around the circle, we said there is what we call the centripetal force. Centripetal force is directed toward the center. Okay, so where there is centripetal force, that is where centripetal acceleration is. Okay, so centripetal acceleration is given by the velocity squared divided by the radius. Then we said that centripetal force Initially, we know that force is given by mass times acceleration, but which acceleration are we talking about? Since centripetal force is the force which is going toward the center, we are going to say this is going to be centripetal acceleration. That's where you are going to see that centripetal acceleration is given by the mass, where the centripetal force is mass, where the centripetal acceleration you put v squared divided what? The radius. Perhaps you have seen this formula. Okay, now we want to talk more about centripetal acceleration here. Now, centripetal acceleration is the acceleration which is going toward the center. But we do know that when we are talking about a linear motion, we only have one acceleration, which is tangential acceleration. Tangential acceleration is also known as linear acceleration. Okay? So in this case, when an object is moving around the circle, we have got two acceleration. We have got what we call the tangential acceleration and the centripetal acceleration. Okay? So tangential acceleration, we know that this has to be acceleration which is going to be in a straight line. So it's going to be there. Okay? So in this case, we're going to have what we call the tangential acceleration. Okay? Tangential acceleration is going to be there. Now, this tangential acceleration, since we have said it is the same as um, the centripetal force, we know that tangential acceleration is going to be, it is the acceleration is given by the final velocity minus the initial velocity divided by the time. But sometimes we know that when you talk about the relationship, you are going to see that you can also use the tangential acceleration, okay, the tangential acceleration to say it is the angular velocity, angular acceleration times the radius. So these two formulas are the ones which we can use to find the tangential acceleration. Then to find the centripetal acceleration, the formula is the same, v squared divided by the radius. Now, the question which they are going to ask you here is to find the net acceleration. Okay? Let's see. So the net acceleration, as you can see, the tangential acceleration is in a straight line. So we are making a 90. So the net acceleration is going to be there. That's the reason why the object is going to be moving around the circle. So what you have to understand is that the net acceleration, if you have the tangential and the centripetal acceleration, you have to say the square root of the centripetal acceleration squared plus the tangential acceleration squared. So you have to find the centripetal acceleration, you square it, tangential acceleration, you square it, then you plug in the values there. Now, in a case where the tangential acceleration, in a case where an object is moving with a constant velocity, we know that when an object is moving with a constant velocity, the acceleration is zero. Now, we have two types of acceleration here. We have got tangential acceleration and the centripetal acceleration. When an object is moving with a constant velocity, what we have to understand is that the tangential acceleration is going to be zero. It's going to be zero. But as long as the object is moving around the circle, we expect to have the centripetal acceleration always, even if it is moving with a constant speed, but it's going to be moving what? The centripetal acceleration is going to be there. So meaning that the net acceleration is going to be equal to, we are going to have only the centripetal acceleration. Okay, so that is going to be the acceleration is going to be there is going to be only centripetal acceleration. So if an object is moving with a constant speed, to find the net acceleration, it's the same of just saying the net acceleration is going to be equal to the centripetal force. Then it's going to be, the net acceleration is going to be v squared divided by the r. As simple as that. Now, another point which you have to understand here is this. They can ask you to say, explain how an object moving with a constant speed can be accelerated. Okay? Explain how an object moving with a constant speed can be accelerated. An object moving with a constant speed, it can only be accelerated in a circular manner. That is what we have to understand. So what is going to be present there is going to be the centripetal acceleration. So an object moving with a constant speed, meaning that that object is going to be moving in a circular manner. Okay, and the acceleration which is going to be present there is going to be the circular centripetal acceleration only. We don't expect to have tangential acceleration because it is moving with a constant speed. Okay, so this is very very important. We need to know this. Now let's talk more about this centripetal acceleration. Okay, we are saying that centripetal acceleration is v squared divided by the r, but we also know that this velocity is given by this is the linear velocity is given by the angular velocity times the radius. So I can replace this with what I have there. So the centripetal acceleration is going to be these two I squared divided by the r. Centripetal acceleration is going to be, so this is going to give me squared, then r squared divided by the r. I can cancel one r, and it's going to be squared divided times r. So this is another formula for centripetal acceleration. Okay, but at the same time we can also talk about the frequency. Okay, but we're going to talk about that later. So we have just to get this for now. So this is what we need to know under centripetal acceleration and the tangential acceleration. In this video we are going to talk about centripetal force. Okay, so centripetal force is a force that makes an object to move around the circle. Okay, so now if we have an object, or maybe let's say we have the circle, now the force that is directed inward toward the center, that is what we call centripetal force. Okay, so now we know that when there is force there is also acceleration. An object can't move without acceleration. So if the force directed toward the center is the centripetal force, meaning the centripetal acceleration is also supposed to be directed in the same direction. So we know that the centripetal acceleration is given by the formula v squared over r. But at the same time, we also know that the force is given by mass times acceleration. So what of the centripetal force? Okay, so centripetal force is going to be equal to the mass times centripetal acceleration. But we also know that centripetal acceleration is v squared over r. Therefore, we are going to replace where there's a with v squared over r. Then centripetal force is going to be given by m v squared over r. So this is the formula for centripetal force. Okay, at the same time, this is the formula for centripetal acceleration. Okay, now we need to understand to say when an object is moving around the circle, we have what we call centripetal force. Okay, that's what we have agreed. But now centripetal force can be represented by many forces. Let's say that you have an object. Let's say you have got a bulb, and then this bulb is supported by the rope. So now the force supported by the rope is what we call the tension force, meaning this is going to be the tension force. Okay, now let's say you are spinning this bulb in this direction along the circle. Okay, you are spinning it. Now as we can see, the tension force is directed inward toward the center of the circle, meaning that we can consider this tension force as what? The centripetal force. Okay, so in this case centripetal force is going to be represented by what? The tension force. Therefore we can calculate the tension force, as we know that the centripetal force is what? Mv squared over r. Okay, now there are two scenarios. When you are spinning this bulb at a very high speed, this is what's going to happen. When you are spinning this at a very high speed, now what is happening is that the tension force is going to be in a horizontal line, which is going to be in this, we can say it's going to be in a straight line. Okay, so when the bulb is moving or is spinning at a very high speed, then this is true, the tension force is going to be equal to centripetal force. This is when we can use the same formula to say mv squared over the radius. But now there's another scenario where we are spinning the bulb at a very slow rate, maybe let's say the speed is not that much high. Okay, let's say this is the bulb. Now instead of it going in a straight direction, this is what's going to happen. Okay, or maybe I can just get rid of this. Let's say that this is the bulb. Now it is spinning not at a very high speed. meaning that it's going to spin at an angle. This is what's going to happen. Okay, so it is spinning. Therefore, what you are going to have here is that this is the tension force. Now, this tension force is going to have the x component as well as the y component. This is when the tension force is not what? Horizontal. Meaning that the bulb is spinning at a very slow rate. We are going to have theta there. So you can say that this is going to be Tx, at the same time this is going to be Ty. Now, how can we calculate the tension force? Now, the way we can calculate the tension force here, because this bulb is at a free, it is moving in a free fall. So we can say that we're going to have also what? The mg in this direction. So this bulb is spinning, it is moving in x direction. Therefore, if it is moving in x direction, the forces in y direction, they're supposed to give us 0 when we add them. So what forces do we have in y direction? First of all, let's talk about the ty and tx in terms of SOHCAHTOA. So ty is going to be, ty is equal to t sine theta. At the same time, tx is going to be t cos theta. Therefore, we can say that the forces in y direction, we are going to have ty which is directed upward, then it's going to carry a positive sign, ty minus, okay. Before we even go there, we know that in y direction we're going to have ty, the same ty, minus minus what? Minus mg has to be equal to 0. Therefore, we can say that ty is going to be equal to mg. Okay, so we are going to be given the mass as well. We know the g. Okay, 9.8. What of tx? So now we know that tx is directed inward toward the center. Okay, so we can say that tx is going to be equal to the centripetal force. So tx is going to be equal to the mv squared over r. So we can get this triangle. It's more like we have this. Okay, we have this part which is ty, we have tx, then we are trying to find t. This is the theta. We can say that then this is true. We can say that t is going to be, we are going to use Pythagoras theorem. So it's going to be tx squared plus ty squared. So we know that tx we can calculate it using mv squared over r. Ty we can calculate it what? Using mg. That is what we need to understand. Okay? But now, we can also calculate the direction using the what? The tan. So we can say that tan theta is going to be equal to, is adjacent, is opposite over adjacent, which is going to be ty over tx. So we can say that theta is going to be tan inverse, then you have ty over tx. So this is the formula which we can use to calculate what? The direction or the angle. Okay. Now, there are some other scenarios which you need to understand. Let's say that the car is moving around the circle. Okay, so let's say this is the roundabout, and then this is the car. Okay, now this car is moving in this direction. So we're going to have what? The velocity. We can say the angular velocity. We can say the angular velocity which we're going to have. Okay, so now if the car is moving, there is a friction between the tires and the load. Now that friction is always directed toward the center. So we can call that this is the friction. Now, since this friction is directed toward the center, then we can say that friction force is going to be equal to what? The centripetal force. Okay? Now, we know that friction force is always mu times the normal force is equal to, we know that the centripetal force is mv squared over r. But we also know that the normal force is given by mg. So we can replace where there's Fn with mg. So we're going to say that mu times mg is equal to mv squared over r. We can cancel m because we are talking about the same car. So we can cancel m. Therefore, we are going to remain with mu times g is equal to v squared over r. Now from here, we can calculate anything. If I want to calculate the coefficient of friction, I'll just make mu as subject of formula. Then I'm going to say it's going to be mu G is equal to V squared over R. And then I can say we divide, or maybe let's say we do times 1 over G. Even here we do times 1 over G. So that here G and G will go. Then we are going to have mu is equal to V squared over RG. So this is the formula which we can also use to get what? The coefficient of what? Friction. Okay. Now, another scenario is where maybe let's say an object is rotating in the drum. Okay. So let's say that this is the drum, and then we have got an object. Okay. Let's say that this is our drum. Now, in here, let's say that we have got an object. Or let's say there is someone inside there. Now, this is rotating. Okay, rotating. Now, allow me to get only this part. So now, I'm going to get as this is the object which is rotating in the drum. Okay. Now, if there is no friction, this object will just fall down due to gravity. So the forces which we are going to have here, we are going to have the mg, which is the force of gravity, the weight force. At the same time, we are going to have the what? The friction force, which is going to be directed upward, so that it will oppose the what? The motion of what? The Fg. Okay, or maybe the force of gravity. So you can say that we have friction force. Now, in this case, since the object is rotating in this direction, in x direction, we are going to say that the normal force is going to be directed inward. So we're going to have the normal force. So when something is rotating in the drum, we only have three forces: the friction force pointed up, the mg pointed down, and the normal force pointed in the direction of what? Centripetal force. Okay. So now we need to understand that since the normal force is directed inward, then we can say that the normal force is going to be equal to the centripetal force. So now this object is rotating in x direction. Therefore, the forces in y direction, when we add them, they're supposed to give us 0. So what are the forces which we have in y direction? We have got the friction force, which is pointing up. So we can say that the friction force minus the mg pointing down has to be equal to 0. So the friction force is going to be equal to the mg. Okay, it's going to be equal to the mg. Now we know that the friction force is given by mu times the normal force, has to be equal to the mg. Now the Fn, we have already said that it is directed inward, meaning that we can replace Fn with what? The centripetal force. Therefore, it's going to be mu times the centripetal force is equal to mg. So what we are going to say now here is that we also know that the centripetal force is given by mv squared over r. So we can replace where there is centripetal force with mv squared over r. So it's going to be mu times mv squared over r, has to be equal to mg. Okay, so now since we're talking about the same object, meaning it has got the same mass, so therefore we can cancel the mass. Let's cancel the mass. So what we're going to have now is that we're going to have, let me get rid of this. Okay, this is what we're going to have. We are going to have the mu v squared over r has to be equal to g. So we can do times, for us to we want to make mu a substitute formula, then we can say times r over v squared. Even here times r over v squared. So the r and r will cancel, the v squared and v squared will cancel, remain with mu is equal to gr over v squared. So when you want to find the coefficient of friction, this is the formula which we are supposed to know. But now physics is tricky. We are supposed to drive these formulas. Just understand the concept. The forces which we are going to have is three forces: the friction force pointing up, the mg pointing down, the normal force pointing in the same direction as what? Centripetal force. This is what we need to understand. Okay, so now let's take, for instance, we have got a funnel. Okay, so if this is the funnel, okay, if this is the funnel, okay, let me draw it. Okay, so if we have the funnel, and then let's say that this funnel, this is what we have. Now let's say that here we are going to be given, let's say we have radius from this point all the way to this point, and let's call it r. And then let's say that we have this part, then it joins there, then we have theta. So let's say that we have got an object which is rotating. Okay, it is spinning inside the fan, the funnel. So what is happening there is that allow me to get on this portion. Okay, now we have this. I've just gotten this part. So now that part which we have there, we are going to have the theta here. So we have an object which is in there. Now this object which you have, we are going to have the mg which is going to be here. At the same time, we are going to have the normal force which is going to be directed in there. Okay, the normal force which is going to be directed there. Now this normal force, since it's not in a straight line, we can say that this normal force is going to have the x component as well as the y component. Then we can also say that according to what is happening here, this theta which is being formed there is the same as the theta which is going to be formed there. Okay, so we can say that this is our nx, which is the normal force. Oh, sorry, that is the normal force. Then this is the normal force in x direction, this is the normal force in y direction. Okay, so we know that this is the theta, this is ny is going to be the opposite. So it's going to be, if I want to find ny, it's going to be ny is equal to n sine theta using SOHCAHTOA. Then nx is going to be nx is going to be n cos theta. Okay, now since this object is spinning, meaning it is moving in x direction, therefore the forces in y direction, allow me to get rid of this. The forces in y direction, sorry, the forces in y direction, they are going to give us 0. Okay, so now we can start with the forces in y direction. Okay, so we can say that the forces in y direction, we add them, they're supposed to give us 0. What forces do we have in y direction? We have ny, which is ny minus mg is pointing down, has to be equal to 0. Now where there is ny, we are going to put n sine theta. So it's going to be n sine theta minus mg is equal to 0. So I can shift mg to the other side. So it's going to be n sine theta is equal to mg. Okay, is equal to mg. Let's call this equation as equation 1. Let's go to the forces in x direction. Since the object is moving in x direction, therefore we can say that the forces in x direction, we are going to have acceleration, which is centripetal acceleration. We are going to have this, the acceleration in x direction. So what forces do we have? We have got nx. This has to be equal to the centripetal what? Acceleration. But we know that nx is given by what? N cos theta. So we're going to say n cos theta is going to be equal to centripetal acceleration. We know that is v squared over r. Okay, let's call this as equation 2. Now what I want us to understand, guys, is that the first equation, let's make n as subject of formula. Okay, so the first equation which we have is I can also get rid of this. Okay, so the first equation which we have n sine theta is equal to mg. So let's make n as subject of formula. We are trying to find velocity. Okay, how fast the object will be spinning inside the funnel. So let's divide both sides by what? Sine theta. We are trying to eliminate n sine theta. So therefore we're going to have our n is equal to mg over cos theta. Now in equation 2, we are going to replace where there is n with mg over cos theta. Okay, therefore this is what we are going to have. So where there is n here, I'm going to put mg. So I'm going to put mg over cos theta. Now times, we have sine theta is equal to mv squared over r. Now what I'm going to have now is that this is going to be like this. We are going to have mg times sine theta divided by cos theta is equal to mv squared over r. Now sine over cos is cot. Okay, sine theta divided by cos theta is what? Cot theta. Then cos theta, okay, Okay, I think we have made a mistake somewhere. It was supposed to be cos theta over sin theta. Yes. Here it is, we have made a mistake here. Because we are saying that we have divided both sides by what? We have divided both sides by sine, meaning that our n is going to be equal to mg over sine theta. Okay, so now where there is n in second equation, we are going to put mg sine theta. Okay, therefore this is what we are going to have. We are going to have mg, I'm replacing mg over sine theta where there is n in second equation, over sine theta times cos theta is going to be equal to mv squared over r. So now we know that cos over sine is going to give us cot theta. Okay, so now we are going to have mg cot theta is equal to mv squared over the radius. This is v. Okay, so we can see that m appears both sides. We can cancel m. Therefore, we are going to have, let me get rid of this now. Okay, so this is what we are going to have. We are going to have g cot theta is equal to v squared over the radius. Okay, now if we have that one, we are trying to find v. Okay, we are trying to find velocity. How can we make v a substitute formula? Let's do cross multiply. So we are going to have cross multiplication. We are going to have v squared is equal to rg cot theta. But we need to understand again that cot theta is the same as 1 over tan theta. Therefore, I can replace where there is cot theta with 1 over tan theta. So we're going to have v squared is equal to rg times what? 1 over tan theta. The reason why I'm doing this is because we don't have cot on calculator. So it's not possible for you to punch cot. Okay? That's the reason I've replaced cot with 1 over tan theta. Okay? So this one is going to be now v squared is equal to rg, because rg times 1 is going to be rg divided by tan theta. Then now we get the square root both sides. We are going to get our v is equal to rg over tan theta. Now it is squared. So now this is the velocity which we are supposed to, this is the formula which is going to give us how fast an object is moving in the funnel. Okay,